Alright, so this is the way I like to do primitive functions, like this type. So if I have a look at the first one, I want to integrate x e to the x squared. Alright, so there's a little weird stuff going on there. So just looking at it, usually the power of e is a good one to let u equal to. And if you think about it, so if I let u equal to x squared, that's the power, then if I implicitly differentiate, so du equals 2x dx. So the same as saying du dx is 2x, but I'm just putting that dx over on the right hand side. So it just becomes du equals 2x dx. Nice and handy. Now if you see, we need a 2x dx. Now if I put a 2 there, I now have a 2x dx. But to balance that, I need to put a half out the front, because really I don't have a 2 there. Alright, so half times 2 is 1, so that all works out perfectly. So now if I change it to in terms of u, which is what I want, that 2x dx part is just equal to du, right? And then the rest is e to the x squared becomes e to the u, because x squared is u. Alright, and then it becomes easy because the integral of e to the u is e to the u. Don't forget your plus c. And just remember to change it back in terms of x's. So e to the, what's u? U is x squared from here. So I get half e to the x squared plus c. Excuse me. Alright, so when I look at b, again, see here, you can see the power. So if I let u equal to the power of the exponential, then du would be 2x dx. So if I set that up, I've got an integral. I want a 2x dx, and here I've got a 4x. So why don't I put it, one of the I break the 4 into 2 times 2. Now it's 2x e to the x squared minus 7 dx. Now I've got the 2x dx, which we can see is equal to du. So it becomes e to the u du again. Alright. And then it's nice and easy, again, to e to the u plus c. In terms of x, it will be 2 e to the, what's u? U is x squared minus 7 plus c. So what do you think for c? We are going to make the let u part. Have a look at that while I'm rubbing this out. So usually, I mean, you can do it different ways, but often the power of the exponential is a great help. So here, let's make u equal to 3x squared, 4x plus 1. In that case, du would be 6x plus 4, that dx. So you have a look, and I haven't got 6x plus 4, but of course if I double that, I've got 6x plus 4. If I'm doubling it, I have to balance it by a half. So if I'm doubling it, which is what I'm doing to get that 6x plus 4, I have to times it by a half out the front, and then I've still got e to the 3, all that stuff, dx. So if I change that now to u's, I've got the 6x plus 4 dx. So 6x plus 4 dx gives me du. And then the other part is e to the u. So again, oh sorry, it was so messy. I've got half e to the, and u was 3x squared plus 4x plus 1. So exponentials are nice. They're a bit boring. Like, in a way, they stay the same, that exponential part. Alright, so if we look at d, again, let u equal to the power, x cubed minus 3x squared. And then we've got du being 3x squared minus 6x. Alright, now don't forget your dx. And I might actually put a 3 outside because that gives me the bracket there. So what I can do here is go, alright, I want 3 lots of this dx to get me a du. And at the moment I've only got 1 lot. So again, if I want 3 lots of that, all I have to do is put a third out the front, and then it's back to balancing to here, which is 1 lot of that. E to the x cubed minus 3x squared dx is a fun, like, rearrangement. So all of this part is du, and then it's just e to the u. So again, I've got a third e to the u plus c, and that is a third e to the, what's u? U is x cubed minus 3x squared plus c. Alright, so what do we want to do for this one again? Let's do u equal 1 on, or x to the negative 1. And then we've got du equaling negative x, negative 2 dx. Alright, and we've got that x to the minus 2 in there already. So if I want a minus, so sometimes if you're getting confused, probably the best way I should have set it up is this is what we want to integrate. Oops, no we don't. That's e to the x to the minus 1 dx. And then I've got this already. So then what I do is I'll look through and I go, alright, I want a negative x to the negative 2 dx to change that to a du. So I need that to be negative, and then I've got it. So to balance that, if I'm putting something in, I need it to be a negative 1 out the front as well. So now that bit is du, and then I've got e to the u there. So you can see I'm going to have minus e to the u plus c as my answer, and u is x to the minus 1, and that's a plus c there. Or you could put 1 on x there instead. That looks nicer. Okay. Alright, so the last one, f. So same with f, I'll set it up a bit nicer for you this time as well. So if you're confused, think about what you're, first of all, what you want to do is you want to integrate negative root x e to the minus, what's that, x root x? Actually, why don't we just change it to index form straight away. So negative x to the half and e to the minus x to the 3 on 2. That's what we want to do. Alright, so let's let u equal to minus x to the 3 on 2. Then that would mean that du would equal minus 3 on 2x to the half dx. Alright, do I have that? Well, I've got the x, I've got the minus and I've got the x to the half dx, but I need this 3 on 2. So what I can do is put a 3 on 2 in there and balance it by putting a 2 on 3 on the outside. So now this whole bit here is just du, and then I've got e to the power of, and that's just u. So that equals 2/3 e to the u plus c, which is 2/3 e to the, what was u? Minus x root x, wasn't it? Yep, plus c. Alright, I hope that helps.